In this video, I want to talk about a kind of open-ended exploration of problem solving through the use of Jupyter Notebooks. And the example I want to use is a simple programming problem. So the problem reads, so you have the numbers 1, 2, 3, and 3, 2, 1. And they contain the same digits, but in a different order. Now find the smallest positive integer, x, such that 2 times x, 3 times x, 4 times x, 5 times x, and 6 times x contain the same digits. Now, what I want to do in this video is I want to go through my kind of implementation of George Polya's How to Solve It book, where he outlines a method for problem solving, which was intended initially for math teachers, but in this case, I think it applies very well to programming problems. So let's take a look. So the first thing that we want to do is ask, what is the unknown? Right? So what is the unknown? Well, in this case, the unknown is an integer number that we want to find out. Right? Okay. So next thing is, what's the data available? So the data available are, in this case, well, math and the rules and logic of math, as well as the numbers that we're considering, which in this case are x, 2x, 2 times x, 4 times x, 5 times x, and 6 times x. So what is the condition? The condition is the main aspect of your problem, right? The core of your problem. In this case, is that we want to find a number with a given set of multiples that will have the same digits between them, right? So that's the general condition. Now, the next question that we have to ask is if it's possible to satisfy the condition. Usually when we do this, it's a bit heuristic where we have to kind of guess based on our first assumption of the problem. In this case, it seems to me that it's very possible. And now one of my favorite parts, break the condition down to the smallest parts. Now this is where we go back to the problem description and we try to break it down, the problem, into its smallest bits in a way that makes it clear what's the path that we have to go through to be able to solve it. In this case, I think that a good way to describe it is, first we have the numbers to consider, x, 2x, 3x, 4x, 5x, and 6x, obviously. They have to have the same digits, and then the answer should be the smallest integer possible. And finally, we have to devise a plan. So now, devising a plan, and when we're doing programming, in my head, would be doing pseudocode. So in this case, the pseudocode for this problem would be, well, we'll start with the number x equal to 1. We'll then create an infinite loop. We'll then calculate 2 times x, 3 times x, etc. We'll then, for each multiple calculated, we'll check its digits. And then if the digits in all the numbers, 2x, 3x, 4x, 5x, and 6x are the same, we'll stop the iteration and return x, right? If they're not, we're going to update x to x plus 1. That will continue until we found x. So that would be kind of like my version of the plan in this case. So let's go ahead, and now it's the phase to execute the plan, meaning writing the code. And we're going to test each component during the process, because the part about plan execution is to follow the steps in the pseudocode while checking that each step is correct, if we can check it. So let's get rid of this for now. Let's forget about these two functions and let's go through so basically, now what we're going to do is we're going to get a pseudocode. And what I do is I just copy it. I copy the pseudocode as comments in the code part. And each line should have an implementation of that line of pseudocode. So in this case, we'll start with the number x equal to 1. We'll then start a infinite loop. We'll calculate the multiples. We'll then, for each multiple that is calculated, we'll check the digits. So in this case, we'll append to a list all the digits from that from that multiple in this case, and then we'll check it. So this function that I wrote here called check digits will check that all the list of sorted digits inside that list are the same. And why sorted? Because the getDigits function will return a sorted list of digits given a number. And why sorted? Because this was in my first view of this problem, the best way to guarantee that we would have we could check the same digits in cases where the digits are out of order, right, with each other. And if that check returns true, we'll break the loop. If it's not, we'll update X. And then the good thing is that when we run it, we get this result, which I know it to be true. So that's great. So this was a simple example. Now what we can do is we can look back and review the code and the solution, right? This should be an integral part of any kind of problem-solving system where we always look back, regardless of having found a solution or not. So we review the code, so we check that everything looks right. We add a little bit of documentation. We check our assumptions. We check our reasoning. We check if we made any kind of like syntax error, that kind of stuff. And then we ask ourselves, can we check the result? In this case, yes, because I know it to be correct, because this is from a list of programming exercises for which I have the solution. And finally, think about how I could optimize the code or derive the solution differently. Can I derive this solution differently? Can I make my solution better? So I look at it as the same. I look at it as the same problem. In this case, yes, I noticed one thing when I was doing the solution, which is for the variable num digits list. Instead of initializing it as a list that I append over the multiple calls of the get digits function, what I could do is just do one list comprehension to make the code a little bit better, right? So I implemented this line, which you're seeing here. And now what I did is I re-implemented the entire code in this cell with this different implementation so that I could compare with the previous implementation. So if we do that now here, we can do a quick check. And we're timing that cell execution to see how our code performs. So this is our results, 1.24 seconds. And now we can test our, let's say, our optimization, our improvement of the previous solution. And now we can check, let's see if we got better. So 1.24 plus 93.5, 1.24 plus 113. So we didn't get like a gigantic improvement. Let's like do another check to make sure. But like we got like a very small improvement, which in this case is great because the point is not to get like a gigantic improvement or anything like that, but to actually just make sure we always try to implement an optimized version of a solution before handing that solution or before finishing with the problem. So here we can see that now it was a little bit better. So 1.33 versus 1.28. So this second version will be our final version, let's say, or the solution to the problem. And finally, before we wrap up, we ask ourselves, can we use the result for some other problem? And in this case, I can definitely use components of this answer for other problems like the functions get digits and check digits. So I'll make sure to create a snippet of those functions because they're clearly reusable for other situations or problems, because sorting a list of digits given a number, that could be reused. This is checking if all the items inside of a list are the same. This is also very reusable. And that's pretty much it. That's what I wanted to talk about today. I want to do a series of sort of open-ended explorations of problem solving through the scope of programming, which for me is super useful. Thanks a lot for watching. If you liked the video, don't forget to subscribe, to like and subscribe. And that's it. Cheers.